So now, with whatever we have learned, we can come to a very interesting point or a theorem, which we can call it as central limit theorem. Let me explain you what is all this. So, number one point for central limit theorem is that if your data points get greater than 30, means for n greater than 30, the sampling distribution becomes normal distribution. That is the point number one. Point number two, sampling distribution mean is almost equivalent to population mean, as we have seen it in the last session where I took an example and explained you in detail. The third important point is sampling distribution standard deviation, which is also represented as standard error, is equal to standard deviation divided by under square root of your number of samples. These 3 points defines your central limit theorem. If you recall from the previous lectures, we have found for that example where the mean compute when we were computing it for 30,000 employee, right, 30,000 employee, we wanted to compute that how much time they are taking to reach office. So for doing that, we took 100 people sample and find their mean compute time. And what we got at that time was that the mean for this was 36.6 minutes, right? This was the value we got. And we have also computed the standard deviation, which comes out to be 10 minutes. We then said that the sample mean cannot be taken as the population mean, as there might be some errors in the sampling process. However, we can say that population mean, that is the daily commute time of 30,000 employee, can be written as somewhere like x mean, which is like 36.6 plus minus some margin of error. Right? Now, you may be thinking that you can use the standard error for the margin of error, right? Even I mentioned that at one point that this is something related to this, but I didn't say that is exactly this. But although the standard error provides a good estimate for this margin of error, you cannot use it exactly in place of margin of error. So you cannot just put the standard error exactly as it is, but yes, it will help you in deriving some value. To understand this why, we're gonna learn it from the next lecture, that how to achieve such things. So we are coming close to a nice solutions as and when we are moving forward.